Hey guys, just want to do a quick little video there and reach the last kind of little section on this pH indicators chapter, and it's relating to acid-base indicators. So we've seen these already insofar as we have done titrations last year, and we've used a number of the indicators already as well. So basically, an acid-base indicator is a substance that changes the color according to the pH of the solution in which it is placed. So it tells us the pH of a substance based on the pH of that substance by means of a color change. Okay, so obviously you can use a pH meter, but in all the titrations we use an indicator. So then when we look at, I was mentioning to you at the time when we did the titration that you'd add a few drops of your your indicator to the titer to the base or in the conical flask. And the reason being is most indicators are weak acids. So what you find is that if it's an acid, it will start neutralizing your base. So if you add too much of the indicator, it's actually going to throw off your titration value. And when we look at it here, you have HIN, so H being the H plus ions, and the IN indicating the indicator, for want of a better word. And that obviously creates your H plus ions in your indicator. And depending on the different colors, then you're going to get different colors in acids or bases. Indicators that are bases then would just have HOH as the reaction there. So you can see it there at that. Okay, so just have a little, because sometimes they ask you to represent the action of an indicator. So the ones we have are acidic acid-base indicators. It goes a little bit of stuff there, not awfully important. What is important though is this chart. So you do need to understand the idea of the range of an indicator. So if you remember back to last year when we looked at titrations, specific titrations had specific indicators. And the reason for that is because depending on what you're reacting together, whether it's strong acids, weak acids, strong bases, weak bases, whatever it is, the range will change as regards what's actually being mixed together or being titrated against each other. So you need to know the different types of indicators, and you need to know the ranges over which they change. I'll explain the idea of ranges in a second as regards to charts when we see the different titration reactions. This chart is really important. So you need to know these three indicators. So methyl orange goes from red to yellow, litmus goes from red to blue, and phenolphthalein goes from colorless to pink, and that's going from acid to base. Furthermore, on top of that, so you should know your color changes already, you should know your indicators already, but furthermore on that, you need to know the ranges over which they change. If you know the ranges, and then you know what you're reacting together with, a strong acid, strong base, or a strong acid, weak base, whatever, if you know the ranges, it's very easy to match up then your indicator to the type of reaction that you're dealing with. Okay, so know your colors and know your ranges in acid, or know your ranges and know your colors in acids and bases. Now, in relation to that then, why am I talking about acids and bases in the context of ranges? So this goes on here on the left hand side. Let's just chat about the type of general titration, okay, with their kind of just mixing together. It's just a titration idea. This is important, okay? They work out from that experiment the range over which indicators change. So what they say is that indicators, normally for our eyes to actually recognize it, the pH range needs to change by 2 to 3. Okay, and as it changes over 2 to 3, we're able to see it. We're able to I suppose, see that color change going from, in the case of litmus, like say from red to blue, from acidic to basic, or whatever the case may be. Depending on whether you have an acid or the type of acid and base you're reacting together, the range over which the pH or the indicator changes varies. So if you have a strong acid against a strong base, think of a strong acid have their pHs obviously down low, strong bases have their pHs up high, and the range for a strong acid, strong base is about 7. Okay, now if you look back, so it's going from pH of 3 to a pH of 10. Okay, if we think back to the range that we had for methyl orange, litmus, and phenolphthalein, we're saying it's going from 3 to 10. So methyl orange changes in a range of 3 to 5. So methyl orange will work for a strong acid, strong base. Litmus changes has a range of 5 to 8. Again, that is within the strong acid, strong base range of 3 to 10. And phenolphthalein has a range of 8 to 10. Again, also in the range of strong acid, strong base. Don't know how much present there. So what we're saying is that when you react a strong acid and a strong base, any indicator will work. Okay, because the range is so great for strong acids and strong bases, any indicator will work. Okay, as you move on then and look at a strong acid and a weak base, we get this. Now if you think strong acid, you're going to be low on the pH scale. Weak base, you're going to be mediocre, so mid to high, or mid to medium high, I suppose, from 7 to 10, give or take. So that means then, we talk about phenolphthalein changes in the range from 8 to 10. So that's not in the range 3 to 7. So that's not going to work for this titration. The other one was litmus, which changed in the range from 5 to 8. Again, not in the range of this. So the only suitable indicator that will work for this titration is methyl orange, because it changes from 3 to 5. Okay, so when you react any strong acid with a weak base, you use methyl orange. We'd have seen this with hydrochloric acid and sodium carbonate as an example. Then, if you have a weak acid but a strong base, so this would be ethanoic acid with maybe sodium hydroxide or something like that. Okay, I don't know what they're using here. Yeah, so they have ethanoic acid here and sodium hydroxide. The pH range, there's a strong base, so therefore your pH is high for the base. Weak acid, your pH is kind of like 7, and close to 7, I suppose, put it that way. So your range for a weak acid strong base titration is between 7 and 10. That means methyl orange won't work, because methyl orange changes from 5 to 3 to 5. Litmus won't work, because litmus goes from 5 to 8. So the only suitable indicator here for this guy for weak acid strong base is phenolphthalein. Okay, and lastly then is if you have a weak acid and a weak base. Now the thing is, with a weak acid and weak base, there is no discernible range over which the pH changes, so you don't get that vertical line in the center. So what we say is that you cannot titrate a weak acid against a weak base, because you don't get a distinct turning point. When you don't get a distinct turning point, basically you're not going to see a color change of an indicator. Okay guys, so that's the stuff relating to pH and indicators. I'm going to add another assignment on here that's going to be due for Friday, okay? And it's going to be some exam paper questions based around pH and indicators. I've received your work from the previous questions and the calculations associated with the pHs of strong acid, strong bases, and then obviously the ones, the dissociation constants for weak acids and weak bases. If there are any problems with any of those, will you please let me know? Anyone in particular you found difficult. And the same with this, when you submit your work, I just need to start getting feedback from you, because obviously I'm not doing the live classes as of yet. But if you give me, even when you submit this stuff in, just kind of say to me that you found question, whatever it was, difficult. And that way then, if I can get a bank of stuff that you can't do, I can put together a quick video and just go through the different issues that you have, guys. Okay, so I'll pop this up on Schoology, and there'll be an assignment going up on this as well, which will be due for Friday. Okay, thank you, bye bye.